Hello, everybody, and welcome. We're going to wait just a few more seconds before we begin at the bottom of the hour. Okay, we will get started. Again, welcome all. Thank you for joining us today in our webinar entitled Effective Data Management. My name is John Hall, and I'm with Novaspect, and we have a team of three of us that will be presenting today. I'd like to introduce Al Samji to you. Al's going to be presenting, and Al's with Emerson. And then Kyle Nystrom will also be presenting. Kyle is with Novaspect. So we'll be back to them in a few minutes. And we've got a lot to cover in the next 60 minutes. It's likely that we will use the entire 60 minutes for presentation. That said, as we're moving along, please feel free to submit questions via the GoToChat. We will take those questions and respond to all. I will send out a single email out to all with all of the questions and all of the responses. So please do send those in. And first of all, I just want to thank you all for taking the time to either watch this in person or watch this in recording. We greatly appreciate it, and we feel this topic is extremely timely, relevant, and important today. And so we're going to share a number of things with you as far as best practices and looking to the future in the data management realm. So I will move forward. We will be referring to and introducing to many of you. Some of you are already familiar with the Plantweb Optics Data Lake, but we're going to be introducing to some of you this platform and specifics around this platform. And the timing is, as I stated earlier, is relevant. You know, right now we're seeing this evolution in the data space where you end users are looking to access data sources that you haven't necessarily accessed in the past. And by accessing them, I mean accessing them and correlating them against each other. And so literally, we're seeing industry move from managing and leveraging time series data, primarily time series data, but now still doing that and doing that very, very well, as we've generally done in the past, but also adding the element of other data sources, other data types, and bringing those together in a way that allows you to do analytics work, to make correlations, to build reporting, to have KPIs available to you all the time, and to help you to make better decisions in your facilities. And so our goal with our platform, Plantweb Optics Data Lake, is to provide tools and support for you to build an environment that's suitable for you today, but also suitable for you as you evolve and as you want to do more and manage more and more data over time. And it's all about, can we create this environment where there's data integration, data ingress from the OT space, and then ultimately, many of you want to build, manage data in the IT space. So how can we move data effectively, again, data of all types, to this IT space for visualization and for putting the data to work? And you'll see an important point on the bottom of this slide is that our job here is to move data securely, efficiently, effectively, and not necessarily store it. I mean, if we need to store it, you'll see as we move along today, there's a very effective and a powerful storage environment within the Plantweb Optics Data Lake. But fundamentally, it's a data integration, data orchestration environment that allows us to connect that OT world and that IT world and do it effectively and efficiently, and of course, securely. So that's the starting point. Okay, so as we're moving through this presentation today, we're going to be referring to some nomenclature. So I'll just put it out there right now so you become comfortable with it. And this is nomenclature within the data lake environment. And we're going to focus on the first half of the presentation around data sources that exist today and providing connector services. So connecting data sources together and moving data through the OT environment to the IT environment. And this core environment is where we'll ultimately move the data through, and we'll leverage Data Studio. So we'll cover and share with you the basics on what's in the Data Studio, with the goal of ultimately egressing the data to the IT space and providing interface services so that you can use whatever visualization and analysis environment that you'd like to use. And as most of you know, there's a lot of visualization tools, there's a lot of analysis tools, and our goal isn't necessarily to promote any of them. Of course, we have an analytics toolkit within the Plantweb Optics environment called Plantweb Optics Analytics, but we realize there's lots of ways to analyze and visualize data, and so we've built the platform to be highly flexible so that we can provide data in whatever format you'd like to see it in. Of course, we'll come back to the data repository later in the presentation and talk about NoSQL and MongoDB and how that can play and how that can work to your advantage in time. So grounding ourselves, the data source and the connector environment is the area that we've put tremendous energy and development in, and not that we haven't in the other areas of the platform, but having the appropriate connectors available has been really important for us. And you'll get the feel here as you see this list of connectors that we've built. Allows us to talk to pretty much any data source. So and what becomes compelling is that not only can we pull information from a process control system, for example, which has been done for a long time, and people do that, you do that very, very well today. We also allow you now to have access to metadata, so additional information that you might not be accessing or leveraging today that you want to leverage tomorrow. And if we think in terms of just process control systems, we can think in terms of alarm information, event information, when things are in bypass, when perhaps a diagnostic data of all types that might be useful for you as you're doing analysis. But this really applies to not only process control, it really applies to all of your data sources. And can we move all of the data that you need or that you're going to want to analyze as you evolve? And so, that's a starting point of the list, and the list actually is quite extensive. You'll see here that we've got all sorts of connectors and protocols and database connectors that we've got available to us to provide efficient and effective movement of data throughout the environment. And this list, goes on and on. So we can connect on the OT side, and then we've got all of our connector and workflow capability on the IT side too. And that's our goal. Our goal is to be able to work with you to help you manage both and do it and do both well. And we're definitely, by providing these connector environment, our job is not to replace your data sources that you have today, but to complement them. And so you'll see as we present today that we happen to use Pi frequently. Pi now, Aviva Pi. We'll use Pi as the sort of the standard from a traditional enterprise historian. Reality is that there's a lot of different enterprise historians in place today, from Aspen and from others. And so we're not looking to replace those. We're looking to complement and help you to not only leverage the data that you've been storing in the Pi space for a long time, but can you also bring other data to bear and move all of that data effectively into your IT and cloud storage environment. So if we take a look at just a very straightforward example of how the data connector environment can play to can be a benefit moving forward for industry. The goal here is to perhaps find ways or utilize the tools to make it provide a much more modular approach to bringing data into an existing data repository. So this is just an example of how we can very effectively build an environment where we use modular tools, modular blocks, connector services to allow us to bring data from PLCs, from DCS, in this case, we're showing Delta V, from emission systems, from different databases that exist throughout the facility, and bring them through a singular environment to manage the, I'll call it chaos, that we have in some of our facilities, using all of the different connector tools that have been used in the past, and create a much more efficient environment and standardized environment to bring data into that enterprise historian that you have in place today. And we are absolutely, happy to provide this support. We want to do this work and to help you bring more and more types of data into your existing enterprise historian, if that's appropriate for you. Okay, so what's the problem? Essentially, why are we here today? We're here today because we're hearing from your team members, from plant managers, from people that work at the enterprise level, from process engineers, from all different personas. Is there a way for us to have access to data real time and minimize the work required to bring it together? And that's what we're building. We're building this environment, and it's built. I mean, it's here. And so it's really a matter of identifying what use case do I want to manage, and from a data analysis, data visualization perspective, what data do I need to achieve this, and how can I leverage the tools to bring the data together for me to put the data to work. And so that's what we're after. And here's just a visual of all that, right? There's all sorts of plant raw data out there from, not only your traditional plant historians, but, all of these other data sources. And I'll show you in a second here, this list can be extensive in many of your facilities, the number of potential data sources that you have available to, answer the big questions that your plant managers have, or your process and maintenance managers have, and other personas in your facilities. All different roles or all different personas have different questions, and having data available real time that's relevant, that's a single version of the truth, can be extremely helpful. And this just gives an example of KPIs, right? Can we create this KPI environment so that KPIs are available real time all the time, rather than being available on a monthly, maybe a daily basis or weekly basis or even monthly basis? Can they be made available real time? And can we satisfy all of our different roles and personas in the facilities to ensure that we're working off of timely information? And as I mentioned earlier, there's just a lot of data sources out there, and they're sitting out there. Many of them are sitting out there as islands in data. And so the question becomes, how can I bring these together without creating a challenging environment to manage and maintain over the long term? And so as we continue throughout this presentation, we'll help you to understand how the modularity of the environment will help with future proofing and making sure that we create something with you that you can easily maintain over the long term. So here's the scenario, right? Most of the traditional OT data storage today is the time series data. We realize that many of you are working to bring together unstructured data together of all types, and so that's why we believe the timing is good for this. And the timing is also good because we realize that the analysis and work is not only being done on the OT side, but that many organizations want to do similar work on the IT front too, or the corporate side or the enterprise side. And so what we're finding is that as we're moving data through the environment, we have some really interesting discussions on the IT side about what's the best way to manage and organize data before egress into the IT data lake or the IT storage environment. So data lake is a relative term, meaning we may decide that we'll just move all data real time into that IT data repository and not need to do any sort of conditioning of the data. But there may be some cases where doing some conditioning might be appropriate and best practice before egressing the data into that IT environment. And as I mentioned earlier, I think this is a pretty good visual of the type of patchwork we've created in facilities to try to move data using tunnelers and servers and clients of all types to try to effectively, build this environment. And this is part of the problem, right? This is a big part of the challenge moving forward, is how can we, best manage this, create something that we can manage. And we're all working towards a solution, and there's no one solution that's going to fit everybody. The solution is going to depend on your circumstances and your infrastructure, what you're doing on the OT side, what you're doing on the IT side, and your cloud storage environment, and can we help you to best orchestrate this movement of data and do it effectively. So we're gonna I think touch on all of these things. Like reducing man hours to produce reports. We're gonna get to that in a moment. We're certainly gonna touch on single source of KPI calculations, but all of this is relevant. Essentially, this last picture I'm going to show you here before we jump into some of the technical items is just the picture of us moving all of these disparate data sources into a state where they can be used to be put to work, and then they can also be used for cloud ingestion. And here's the goal, right? Can we take on these different use cases to add value and bring value to our organizations? So I think you got the picture on why we're doing this, and the benefits. The why are there benefits? Real-time information, doing less work to bring data together, and being ensured that the data that we're analyzing is current and appropriate. But will all sorts of benefits. And one of the picture here is on the picture of specifically the sort of final summary on data lake ingress, egress, and future proving, doing things securely around the cyber side, cost effectively, and can we create this rapidly, also rapid implementation. All right, that was just the groundwork to get us started. I wanted to limit myself to the first 20 minutes here because I really wanted us to get to this slide as we moved into the more technical overview from Al and then Kyle. Really, this is the heart of the discussion, is our future proofing. What can we do today to ensure that how can we work together to ensure that you're going to be in a position where you can be successful 2 years from now, 5 years from now, and beyond. And these are big questions here that we're going to be addressing as far as managing the tunneling between OT and IT networks, load balancing on your OT networks, especially as we're moving lots of data, compression and encryption of data as it's transported. Can we do things securely and make sure that your data is managed as securely as it possibly can be? Do you have a store and forward architecture in place so that if you do ever lose connectivity, because it does happen, right? It does happen at times. Can we be assured that that data is going to be backfilled, and and that's always in place. And orchestration of communication. Can we, item number 6 there, can we move data through a single TCP connection? And can we do it, using multiple, minimum ports, firewall ports, right? Keeping connectivity to a minimum number of connections. And then monitoring and managing connections. And then finally, number 8, maybe the most important of all of these, is data reads. Can you be in a position where, as you're consuming and where your users want to consume more data, can they read data in a way that's appropriate from their perspective? And we'll get to this as we talk, go through the technical discussion here, that the read capability within this environment is an order of magnitude better than what's available with traditional databases. So a very attractive part of this entire scenario, because at the end of the day, we're creating the infrastructure for users, and it's the users that will want to read data, retrieve data as quickly as possible. And we'll explain that this environment provides a mechanism to achieve those sorts of outcomes and performance in data reads. All right, I'm going to pause there and move it over to move to the next slide. And Al is going to jump in now. Oh, this is, yeah, Al, you're going to start from here. I'm sorry.
Sounds good. Thanks, John. So yeah, just a quick revisit of this slide. Again, this is a sort of a similar looking architecture that from what we typically see, but it's also a bit different in that we have connectivity from devices in the field, the PLCs, pulling that data in. But we also look at some some of the typical endpoints like a historian system or other line of business systems as other inputs into this architecture. And with that, we're able to sort of bring in data from these stranded data sources, as well as tying together different types of data in a single pane of glass. So it's just really about sort of adapting to the situation and being flexible as to the needs, because the capability to pull that data out from different sources is there, and the capability to effectively and efficiently store that data is there as well. So in this case, we're looking at OSIsoft off Pi as an input, but we also have connector services for other historian systems as well. So John, if we could move to the next slide, please. So here we have an example where we're showing a screenshot of our Data Studio application. And here what we're looking at is an example where there's a component that's synchronized between the Pi asset framework and an item in the IO model, which is kind of a one spot to organize the landing spot for the data inside the data lake. And really the point here is to say that, again, building on John's comment, it's about the complement between the systems. So you don't have to rebuild what's been done, and you can simply leverage it for what you need to, instead of reinventing the wheel from scratch. So your hierarchy from your asset framework can be synchronized so that it shows up, or certain parts of it show up within the IO model within the optics data lake. Next, please. Yep, thanks. The architecture of our system is open, and it's cloud ready. So where often what the major asks from our customers is that, okay, yeah, we have our data on premise, but we want to take advantage of um, the new tools out there, like uh, machine learning, big data analytics. Those types of applications are being democratized. It's easier and easier to make use of those technologies. They're becoming more practical to use. And guess what? We have some use cases now, but we don't know how to get that data up to the cloud in an efficient way. Well, that's something that's been considered with this platform, and we have the ability to stream data from our platform to the cloud-based systems using MQTT, Kafka protocols, really cloud agnostic. So whether it's this diagram depicts an Azure ecosystem, but that could easily be Google or Amazon as well, right? But taking that data, taking it to Event Hub or IoT Hub, then landing it into our cloud data lake, where then we can do other things that we want with it. So um, we really can just help you get your data to where you need it to be with the multitude of tools that we have. So and not just necessarily a data lake or IoT hub or event hub, but like one of the slides that John showed was, we have a number of other direct connections possible too. So if you want to, update Power BI directly, and not necessarily go through the data lake, well, we have some flexibility and we can support those different types of workflows and data flows, if you will. Next, please. Yeah, thanks. So this is another example of a sample architecture which depicts data collection from different sites. So we see data collection from an Aspen historian, an OSI soft historian, SQL Server database, as well as a couple of other ingestion methods. And um, with that, you have your data collection coming into our core ecosystem, where on the left side you have sort of a traditional clients where you have the ability to look at that data through Excel, through Power BI. Our data lake has a native web-based client visualization tool called Web Studio, which is a purely HTML5 JavaScript-based application. So that's gives you the ability to visualize that data as well. There's visual KPI as well, and visual KPI is the application from Transpera, and our data lake has a close integration with that. In a few moments, you'll see me talk about the KPI model. So there's a close integration. So there's a number of different choices for data visualization. Coupled with that, in a few months we will be also adding to that platform with the Optics HMI. So there's a new series of thick and thin client tools that we'll be adding to the portfolio soon. But there's needless to say, there's a number of ways to actually for end users to interact with that data. There's a mention of the REST API, and we'll go into that into a bit more detail, but that is also a capability there. Now, on the right side, we see some other applications. Again, looking at the cloud based integrations and basically other types of non-human interaction, but computer to computer or system to system integration. So whether it's cloud-based systems, or if you want to, pull that data into other systems, we have an OPC UA server as well. And so that can be used to then treat the data lake as a data source as well. So if you have a visualization tool that you want to use that just uses OPC UA, you can use that as well. So a number of different options all around to both for end users as well as from a programmatic or system to system integration standpoint, backed by the uh, data lake architecture that we have here. So our software has the ability to traverse different network layers as well to adhere to um, cybersecurity guidance. And so what, oftentimes we'll see customers with this type of a prototype architecture where you have L2 at the site, where we're collecting data from different data sources down at that level. And then sometimes you might have an intermediate data store at level 3, as well as other sources of data at that level as well. So what we have is a relay mechanism, which it's used to send data up the network layers so that we can eventually land it within the core system. So at each level, we can have secure data collection, and that data collection can go through multiple network hops through this relay component, and then eventually make its way to the core repository, which typically sits at the L4 level. Although we can have it sit at the cloud level as well. So it's just kind of an example of an architecture style that we see across many clients. Um, Talking about security a little bit, so modern, a lot of the modern authentication and security standards and protocols are supported with the platform. So make use of TLS when the data is in transit and the information, is sent through a single configurable TCP port so that it's firewall friendly. On the client side, when the data is sent through encrypted channels, and our REST API also supports modern security features like OAuth and JOT tokens as well. So there are a number of other security standards that we support as well at the data persistence at connectivity levels, and that's something that we can provide more information if needed as well. But it's security is something that has been not an afterthought. It's from the ground up, it's been built securely. So yeah. Um, Next slide here just talks about another sort of a use case scenario where we have the ability to connect to ERP systems, so SAP or other systems. And in this case, with the example of SAP, whether you're looking at materials, inspection data, or production data, this can be achieved using integration with SAP to get IDOC documents. Alternatively, we can also make use of web services where available. And the interesting thing is that Optics Data Lake will take care of the data conversion. So whether you want to parse that data and store that within your IO model, or you want to store the data as files, that's possible through the MongoDB backend, which is what is used for the data lake. So there's a GridFS file system that can actually store files. So there's lots of possibilities, and it's quite flexible with what can be done there. And speaking about the database repository, MongoDB is probably the most famous NoSQL database that you probably have heard of, which is extremely scalable, both vertically and horizontally as well. It's a back end for Netflix globally as well. So you can just imagine the scalability of it. And so Optics Data Lake uses MongoDB to store its data retrieved from the information from the various points of information. And there's several advantages to it. So first of all, the data is stored in an open format, right? So it's not locked away proprietary. It's scalable, and you get the benefits of the replica sets and the sharding and the high the massively scalable architecture of MongoDB. Um, there's also a number of different client libraries that you can use in different programming languages like C# to get at your MongoDB data. Going back to the comment John made about read performance, one of the things that MongoDB does is it has uh, a very high read performance that's been measured to be far greater than typical historian read performance. So that's certainly an advantage. The one other thing to mention here with MongoDB, because the data that's stored within the database is stored in collections. So you have databases and then you have collections, and within the collections, although time series data typically has a schema, right, where we have the value and then the time and the quality, but you know our data lake allows a customized data store capability as well. So you can actually store data that doesn't necessarily have those three attributes, and it can have its own sets of attributes, right? And this serves us well for specialized use cases. If you want to in some cases store some type of metadata, or you want to store other non-standard data that has a JSON schema, but it's different from what you would typically use. That flexibility is there, so you can have your own types of data types in there and data sources in there, and you don't need a separate database. You just you can use the same data lake architecture, and throughout using the extensibility tools, using um, the scripting available within the Mongo database and our data lake platform, you can take advantage of that data that's stored in the different formats. So it's really an advantage to have that MongoDB. Touching a little bit on the data models here. So we talked about the IO model briefly, where that's kind of like the landing spot for our data, but there are a couple of other ways to organize the data. So this is where we can define models. So there's a couple of different ways. Firstly, with the ISA 95 model, it's more around the enterprise, site, plant, unit, equipment, kind of a hierarchy where you can define assets, and your process variables or the historized data components can actually map into your ISA equipment model, which can then be made accessible to you through the client tools to view that data within a context. Um, the other model that's available is the KPI model, which treats it's a bit more flexible with the organization of it, as you can have groups of KPIs tied to assets, and you can have upper and lower limits. And when I talked about the integration with the visual KPI, this is where if you have that product, it plays well with the data lake, because the KPIs that you set up in the KPI model with their limits and their their data sources are automatically transferred to the Transpera system when that integration exists. So it allows you to visualize the data using Visual KPI as well. So a lot of flexibility around how to view and structure your data and organize it, so it's not just a a big list of data streams. Yeah. Yeah, we'll move on to the next one here. So Lua scripting. So Lua is the language that is used by the data lake for scripting, and it's used for you know a number of different cases. It's used to put together scripts to perform data cleansing, to do calculations, any kind of business logic, or if you have some some need that some sequential or periodic uh, you know changes that you need to do. It's very fast and very relatively simple to use, but really helps to extend the core capabilities of the data lake. And it's got an extensible set of modules as well. So there's modules that you can reference, and when as shipped, it provides a lot of helper libraries. So a lot of uh, uh, basically common code use cases are already developed for you, and there's examples on the web for that. So it's a tool that can use to extend what you've got out of the box there. Store and forward capabilities, so it's almost as a commodity feature, but really when you're thinking about it, it's actually a key feature that's really critical, because when you're talking about data collection from remote networks, there's going to be definitely network drops in between, and the data lake has a store and forward capability, which will hold on to the data until that connection's back up. So, we'll use a buffering until the connection is activated again, and the data will flow through. So it's simple to explain, but it's actually a critical capability that the data lake does provide. Um, the this what this slide really just talks about is the ability to transfer historical data from external sources. So the system is getting a bit into the nomenclature of the system there, but there's what we have called history transporters, which read data from external systems. We have something called history sinks, which we can use to write data to external systems. And then the controllers are objects which basically monitor that process and administer it. So, but again, the main point is that it's possible not just for real-time data, but it's possible to transfer historical data back and forth between systems as well. This is a screenshot of our Web Studio tool, which is the web-based client that's built off of HTML5 and JavaScript, and it's based off of the D3.js library. You can see that you can do trends, tables, static images, as well as data from other systems. And one other thing I want to mention is that there's an open source library called Plotly. Web Studio supports uh, graphics using the Plotly library as well, so you can use any of those graphics that you see. Go to the Plotly website, and those are configurable. So it's a very declarative environment where you have JSON to basically configure this screen, and it's a simple authoring experience, and not you don't have to get a pull out like a report authoring tool for this. Um, Next slide, please. Yeah, so this is the StimulSoft reporting engine. Um, this is again an example for a component that's actually part of the data lake for reporting purposes. And so we have a report designer actually. So this, these reports are reports that you can save and print, and it's paginated, and it's, you can view them on the web as well, but you can also view them within Data Studio, and you can schedule them as well. But I guess at this point I would like to invite Kyle. I think I'm talking on his slide. Sorry about that, Kyle, but I'll let you carry on and continue the rest of that.
No worries. So thanks, Al. The only thing I would add to that Al didn't put in is, so I think this is one of the differentiators that we have between, say, using this in Pi, is this embedded StimulSoft reporting tool. So what you're able to do is you're able to bring the IO information that you've embedded now on the IO model, and then bring it over into the reporting tool, and do that using a Lua script that will allow you to bring the data in and then drag and drop to build this report. It's got a website onto its own on the StimulSoft, so there's many options for you to be able to do. But as you stated, you can also use this to run a schedule and then print it off and keep it in a repository of a PDF or an Excel file. Next slide, John. So here's the one of the other differentiators is working with batch. So in the Pi World batch, you now bring it into event frames. So if that's already in your environment, we can help utilize that to bring into something like that report. And then we could use that as the production device, or you could be looking at Delta V, for example, and go into the batch executive to be able to pull in this information. And then what you're able to do then is parse this information and lay it out so that you can store it. And then once you have it stored, you can build this tree structure to make sense of what that batch information is. And then you can be able to build the report, as I said, using the IO. So you can do that, or you can push it using a web API to write it up. Next slide. So speaking of web APIs, so when we want to speak to different pieces of information up on the IT network, web API is usually a pretty standard way of doing it. There's also REST API, as Al made reference to, but the web API, which is native and doesn't need IIS to be able to do this, but it also creates security that you can have. It uses WebSockets and HTTP to push the information. And this allows us to communicate with various different information. So as long as you have a way of getting the data and pushing the data, you can be able to do that over the web API. Okay, some of those things that you may be writing a web API to are business intelligence tools like Power BI. As we said, visual KPI is a little different as we have almost a partnership in the KPI realm that it does the transfer for. But there's other information that you want to push right to different sources, and Seek, for example, if you want to do a little analytics on, and in collaboration, we work with them all the way down to your science, your MATLAB, which I used in college to be able to do analysis of data. Out to the cloud, you saw that whole list that's out there with whether or not we want to publish data, whether or not we want to stream data, whether or not we want to put it to another data lake. All those are options. And then writing to open source stuff, so people that want to write scripts with the web API can then pull that information and do with the data as they want, like Python, or R. Okay, more examples of what that will leverage us to do is, here's an example of what Spartan, an Impact partner, was able to build inside of using some of the information. I believe this is in Power BI that we see this displayed in, but all these roll-ups. So what they did here is they almost made a health score summary using stuff that they pulled out of AMS Device Manager. And they were also allowed to build the alert dashboard down below. So they're able to utilize, show a calendar of when things were not available, show uptime, show availability, show anything that's in alert. All this available right on a screen that you can, if you're on the network, remote into, or use your URL to be able to see the information. The next one is alarm. So now we want to be able to show a bit of something that I think is pretty underutilized in the Delta V world, which is alarm and events, and be able to use the OPC A&E server to be able to push information. So now this isn't a replacement for AgileOps. This is for alarm rationalization. This is to utilize information to show what the report is, where you're not doing any of the information that AgileOps would be doing. You're not replacing that. What you're doing is just displaying a report that shows you the bad actors and everything that you've had and over a time frame. So that want to make that abundantly clear in this. And what they show in there is a bunch of KPIs that can build. And right here on the non-traditional use cases of A&E, there's a good example of different examples like SIS, security, safety stuff that we'll go through. Next slide. Which is right here. So there's two slides here that are relatively the same. This is showing you loop management, which you'll see connectors to pretty much the same equipment as we will with the SIS example. So if you want to go to the SIS example and 2 slides down, John, I think that'll make more sense. So in the SIS, you're going to Delta V and the Smart Commissioning, which has a SQL database. If I remember, you're pulling in document management, so flat files, SPI, which is another database, and RFID system, which could range from just a database to something like Eschbach Shift Connector, which might have the RFIDs on there. So a whole bunch of ways to show you that we can integrate and help with the SIS checking, so safety. If you want to go up one, John, we can do the other example if you want. Again, rotating equipment is near and dear to quite a few examples that we're doing these days. So being able to pull in reliability information, so online vibration, pulling your MHM information up or bringing it straight from the wireless. Portables, so the handhelds that we have. So once again, MHM might be involved. Oil analysis, that I believe that's a different company now, but it also has a SQL database in the one example that we're using. SPI again, different database, and then a RFID system once again. So all these will allow us to be able to give key alerts and give you the information, much of what we saw like in Spartan's KPIs of information, just change it to rotating equipment or inventory or anything that you want to do that allows with the different connectors once you start contextualizing all this information. Okay, one of the big asks is overall equipment effectiveness, which OEE. So many customers are trying to figure out what their uptime, what their downtime, why, and what the issues are, and what did we lose, and doing the calculations when we're not, for one customer, we're on their line that's running at 80%, which is costing them. So we've put in vibration, and we'll put in data lake to grab that vibration information, and from a couple PLC sources to be able to show them to start building their overall effectiveness calculation. So the next 4 slides are going to be an example of a refinery of Houston and all the data that we can show and put on a Power BI display. This is showing the overall period of what's happening in each of the units out at the refining facility. And then it shows some of the security happening. So it's just the bottom right-hand corner is the new fancy, we haven't had a incident in how many days chart that they wanted to show down on the bottom. And then they're showing, I'm not a refining expert, but it looks like exactly what their production has compared to what they were expecting. And in the middle, you can see that, excuse me, some of the information shows you that they're a little behind or they're overproducing on some of them. The next chart is really to show you just pie charts and bar charts and all the different charts that you can use, showing you the information. And this is taking in expenses from the business side and using that to show with the uptimes and showing them how effective and how overall business is working. again, showing off just some of the tools that are embedded inside the BI and the different information that you can pull from different information. This one comes from a CMMS system of some sort, and that CMMS system allows them to pull that information and showing when they had uptime and downtime information in different formats. And then the last one is reliability. Reliability could come from MHM. It could come from different reliability options. But this shows you the ability to be able to pull that data and start showing you again which pieces of equipment were in critical and which had to be shut down, and the information on the uptime in those months, and showing you the bar charts.
Thank you, Kyle.
Mm-hmm.
And Al. So I'm going to finish off with some summaries of what we went through with you today, trying to cover several of the future-proofing concepts and components that we mentioned earlier in the presentation, and trying to create just a summary for you. So you can read each of these. What we showed today is that Plantweb Optics Data Lake is a service-based architecture that's very modular, and it allows us to ingest, manage all types of data from all types of data sources, structured, semi-structured, unstructured. We've got this built-in data modeling environment that gives us a great deal of ability to be flexible and contextualize data as required. Obviously, we're going to be able to talk to all sorts of data sources. We didn't mention the ability to support high-speed resolution or high-resolution data. So that is in the deliverable part of the portfolio. If I go on to the next slide, obviously it's essentially managed enterprise environment. So we can work at the site level, we can work at the enterprise level, we can work at both, and you can manage it all from a central environment. Obviously, we're supporting mixed architectures. We're good with doing everything on-prem, obviously supporting the cloud environment, or supporting both at the same time, and working with all sorts of cloud providers. We just list the big guys in that next list there, but we'll work with literally any service provider that you would like to. Using open interfaces, as we talked about, we include a scripting environment that gives us lots of flexibility, and designed to support the OT professionals and the IT professionals out there, and do it appropriately. The two last bullets are perhaps the two biggest pieces of information to share about our position in the space. Is that, first of all, we are not using a tag-based licensing model. We're using a core-based licensing model, which makes the platform very attractive, not only for our small installations, but also for scaling to handle lots and lots of data and movement of data. And so the commercial implications are big. And as we talk to you about your applications, you're going to see that the licensing model is quite attractive in comparison to the traditional licensing that's been out there. And then Al did a really nice job of highlighting the read performance, and satisfying your users over time, creating an environment where they can read data, especially where they want to pull big data sets and pull things quickly. You're going to find that your read performances are at least an order of magnitude better than you're going to be able to manage with a traditional storage environment, and potentially several orders of magnitude better. So that's very exciting for industry for sure. And then lastly, we're coming up on our 1 hour mark here. I just wanted to explain that this data lake environment is central to our overall Plantweb Optics environment, starting at version 1.7, which is planned to be released by the end of the year. So the data lake is available today as is, of course, but at version 1.7, Plantweb Optics Data Lake and Plantweb Optics Portal become the same environment, which provides great flexibility for you, the user, in that we allow you to bring in for any information into the portal environment, because portal is inherently connected to the data lake environment. So what that means for you is for the Plantweb portal environment. It allows us to talk to any data source, bring in any data source into the environment, and create alerting and information sharing in that portal environment around any data source, not just Emerson data sources. And the Emerson data sources obviously are very important to us and to many of you, but we wanted to make the platform as flexible as possible so that we could allow you to visualize data from anywhere. And so Plantweb Data Lake is clearly at the center of our environment moving forward. And obviously the analytics environment is complementary and available to you, and that's also important to us. So we'll share more on that in future discussions. So we're going to end there. A few things. First of all, I want to thank Al and Kyle for their presentations and contributions. So thank you very much. Thank you, Chris Connell, for setting up all the logistics for today's presentation. As I stated earlier, I will send responses to any questions that have come in the last hour. So if there's any final questions, please submit them now, and I'll get those all answered and those responses out to all of you. We would be extremely happy to provide any of you, conversation, customized demonstration. We can show you any of the elements of the environment and create some reporting examples for you, or any examples that you would like to, based on whatever visualization tools you'd like to use. And so just please be in touch with myself or anybody else on the Novaspect team. And lastly, just an invitation to you, if you want to have a discussion about future-proofing your data environment, we obviously would love to be in that discussion. We've got lots of experience and expertise on our team, and so Kyle and Al could be parts of those conversations, but we have many others on our team that are dedicated to this space and can provide lots of insight for you. And then lastly, thank you for joining us today, or if you're watching the recording, thank you for watching the recording. And we'll talk in the future, and have a good day. Thanks all.